Okay, good day, everybody. Welcome to this session. This is a session on NS1 revision, and I've compiled quite a lot of questions, about 75 of them from past exam papers, so that this can help you to kind of like revise and see how you're going to be assessed. Okay, so before we look into this question, I just want us to revise a bit on the atomic theory. So this is a session on chemistry. There will be another session that I'll record separately for physics, right? NS1 physics. But these are only questions on chemistry that we're going to be looking at. It's MCQs from past exam papers. All right. Before we look into this question, guys, let us start by revising the atomic model or theory timeline. Okay. This is very important because also your lectures mentioned that you have to kind of like know this. I'm sure you want to assess it, highly likely to be assessed, so it's best that we revise this. Okay, let's start here, guys. Atomic theory, atomic model, it's quite a very interesting model because it really shows us that really scientific knowledge changes over time when new and new discoveries are found, right? So it starts with the scientist Democritus, I think it was 400 before Christ, where he actually says that all matter is made up of these very small particles, which he himself called atoms, right? He called them atoms or an atom, right? It says all matter is composed of these smaller particles, which are called atom. This is Democritus, right? Then later, John Dalton, this is John Dalton. I think maybe in the next slide it's quite clear. John Dalton comes in 1803 and says that, yes, Democritus, you're right. Atoms are made up of this small, matter is made up of these smaller particles called atom. And he actually extended that definition. He said, but these smaller particles, these smaller building blocks that you are calling atoms, we cannot divide them any further. They don't have smaller particles within them. That is, they are indivisible. This is John Dalton, guys, in 1803, who says, these smaller building blocks, or what Democritus is called atom, we cannot divide them any further. They are very small, such that they cannot be divided any further. Okay, this is John Dalton. Guys, J.J. Thomson comes in 1897. You don't necessarily need to know the dates, right? You need to know who discovered what, right? J.J. Thomson comes with in 1897, and disreputed John Dalton discovery, right? He said, no, John Dalton, that is incorrect. Atoms also contain some smaller particles within them. Remember, John Dalton is the one who says the atoms are solid spheres which cannot be divided any further, right? But J.J. Thomson says, no, he discovered that atoms within them, they also contain some smaller particles called electrons, right? So J.J. Thomson discovered electrons within atoms. That no, there are other smaller particles within an atom. The fact that you, John Dalton, are saying atom cannot be divided any further, it's false, because me, I've discovered that there are actually smaller particles called electrons within an atom. And how does he explain this? He uses the plum pairing model, right, to kind of describe how these electrons are positioned within an atom. He says they're like in a plum pudding, right? Let me show you a picture of a plum pudding. It's a plum pudding. He described them like electrons are embedded just like in plum pudding, right? So guys, this is a plum pudding. As you can see, it has some plum within this pudding. So this is how J.J. Thomson described the presence of electrons. J.J. Thomson discovered electrons, smaller other particles within an atom. He says they're positioned, they're placed like in a plum pudding, like a plum in a pudding, right? So that is how electrons are positioned. And that pudding will represent like a sea or a pool of positive charge. And then electrons are positioned there. But he didn't necessarily discover positive charge, guys. What J.J. Thomson discovered is electrons. And he says they're embedded, just like in a plum pudding, using the plum pudding model to describe, right? Guys, later in 1911, Ernest Rutherford actually discovered other smaller particles within an atom. Remember, J.J. Thomson discovered electrons. Ernest Rutherford said, no, Thomson, Electrons are not just embedded throughout that, like a sea of positive charge. They're not embedded in that sea of positive charge. However, positive charge are actually at the center, at the nucleus. So Ernest Rutherford discovered the nucleus, right? Through his experiment called the Godfoil experiment. I think it's very important for you to understand this, guys. Let me just also show you the Godfall experiment and describe how did he actually come up with this. The nucleus. Remember, J.J. Thomson, he discovered electrons, small other particles within an atom, embedded like a Plum-Parry model. However, Ernest Rutherford actually says, no, 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 Thomson, they're not just embedded around that sea of positive charge. However, those positive charge are at the center. There's actually a nucleus within an atom. Okay, and he discovered this through the what? The his Godfoil experiment. How did he discover this, guys? Let me explain this Godfoil experiment. Now, what he did with this experiment, right? So what he did, um, he actually used alpha particles. So alpha particles are positive charge radiation, right? So he emitted through a radiation emission source, alpha particles, which are positive charge, right? Then what he did is he shined them through a gold foil, right? So this gold foil was very thin, such that it's almost representing an atom. It's like you are shooting in an atom. You understand? And he's shooting positive charge, this alpha particle, in this atom, the thin gold foil, right? And what he noticed is that some of these alpha particles were being deflected about in the center there. They seem to be deflected. And he actually predicted there must be another positive charge at the center because I'm spraying positive charge. Why are some repelled getting backward, like this one getting backward? Some are managing to pass, but however, some of them are shooting backward, right? Because he used this detector to actually see where they will be deflected towards, right? So he saw that some of them are being deflected backwards. And he discovered that, oh, there must be a nucleus as well that is positively charged. So Ernest Rutherford discovered positive charge, the nucleus, right? At the center, he discovered that no, there is a nucleus that is actually deflecting or repelling this positive charge that I'm spraying or that I'm emitting towards this atom. You understand? So that's how we discovered it through the gold foil experiment. Okay, that is Ernest Rutherford. Okay, you can see that, more things are being discovered over time. And then, but Ernest Rutherford just say these electrons, he didn't dispute J.J. Thomson presence of electrons. However, he just said these electrons are just around that nucleus, but there's a center, there's a nucleus, right? Then what then happened is that later in 1913, Niels Bohr actually described the location of those electrons. And he says that those electrons are actually are just not around the nucleus in anyhow, but however, they are actually located in circular orbits around the nucleus. And this is the Bohr's model. Do you know the Bohr's model is the one that you draw these circular orbits and you show electrons there, right? It's actually named after Niels Bohr, right? He says that no, 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 no. Ernest Rutherford, electrons are just not around in anyhow the nucleus. However, they are positioned in circular orbits around the nucleus. Okay, so he kind of like give us that nice diagram that shows us the location of electrons around the nucleus, that they're not just in anyhow, but however they are positioned in circular orbits around the nucleus. Okay, then later in 1926, but you don't necessarily have to know this, but it's quite important maybe, Erwin Schrödinger actually disputed Niels Bohr's model. He argues that no, 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 electrons are actually moving at very, very high speeds around the nucleus, such that they are forming a cloud around the nucleus, right? That electrons are in cloud surrounding, they're not in circular orbits. However, they're moving around at very high speed, such that they are forming a cloud, that is this cloud that is around the nucleus. Okay, this is atomic theory timeline, guys, and it's very important because it actually shows us something about the nature of science, that science is synthetic knowledge, that science can change over time. When other scientists come and discover more and more things, they can actually dispute what has been said in the past. So scientific knowledge is not absolute knowledge, however, is synthetic. And this is the nature of science, that is synthetic, that it changes over time, that as more people come and discover and more things, then we can actually distribute all knowledge. It can be improved over time. That is scientific knowledge. As you can see with the atomic theory, in the beginning, in 400 BC, they used to just believe there's just an atom. All matter is made up of an atom, right? Like small building blocks. However, John Dalton comes and said, no, by these small building blocks, we cannot divide them any further. J.J. Thomson said, no, 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 no. Actually, within this atom, there are also other smaller particles. That is, we can divide them. There are other smaller particles within an atom called electrons. He discovered this and he showed it through the Blampari model. And Ernest Rutherford says, no, 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 there's also a nucleus, positive charge at the center of that atom. He's discovering more and more particles within an atom, right? Niels Bohr described the position of those electrons in circular orbits around the nucleus. Then Edwin Schrödinger says that they're actually in a cloud-like formation. Okay, I think this is very important for you to know. I think at this point we can now jump and look at these questions. Quite very interesting, and let's see how it goes. All right. All right, let's now look at this question. NS1 revision from past papers, chemistry MCQs. First question, which of the following scientists is credited with developing the first modern atomic theory in 1808? Who is the first one who is credited with developing the first modern atomic theory, guys? We know that it was Democritus, then who? John Dalton. Okay, but yet there's no Democritus. Obviously, the first one from all of this one will be what? John Dalton. Okay, let's move. Who is credited with the development of the modern periodic table? So if you check periodic table, guys, they're written the name of the guy. It was Dmitry Mendeleev, right? Dmitry Mendeleev is the one who actually discovered the periodic table, who developed it. Okay. Normally they write him like in those periodic table. If you check your periodic table at the end, they normally write his name, Dmitry Mendeleev. Is that older man with, I think, yeah, with funny, whatever. So it's Dmitry Mendeleev. Number 3, who is credited with the discovery of the electron? We have discussed this, guys, through the Blampari model. J.J. Thomson discovered electrons. Okay. 4, who is credited with the discovery of the nucleus? We have discussed this, guys. We know that Ernest Rutherford is the one who discovered the nucleus through his gold foil experiment. All right. Number 5. Which of the following statement is correct about the location of electrons according to the Bohr model of an atom? What does Bohr say, guys? Bohr says electrons are located in circular orbits around the what? The nucleus. Okay. Who talks like electrons are arranged in cloud-like formation? This is what? Erwin Schrödinger, isn't it? Erwin Schrödinger is the one who talks about cloud-like formation, right? So, but the one who talks about, the Bohr's model, obvious, it's Niels Bohr, who talks about electron be located in circular orbits around the nucleus. All right, let's go to number 6 now. Which of the following is the correct conclusion that may be drawn from the results of Rutherford's gold foil experiment? What can we conclude about Rutherford's gold foil experiment? How did he discover the nucleus, guys? Let me remind you, he discovered the nucleus by noticing that some of the alpha particles were being deflected about the center. Okay, that's how we discovered it. Okay, so obviously the correct answer there, which of the following can be drawn as a result of Rutherford's gold foil experiment? Some of the alpha particles are scattered by the nuclei of the what? Of the gold atoms. All right, this would be our correct answer there. because some of them were being scattered by that nucleus of that gold foil atom. Okay, and that was the case. What particles are found in the nucleus of an atom? Guys, in the nucleus, we only have what? Protons and neutrons. Okay, so in the center, there is protons and neutrons. Remember, protons are positive charge, neutrons, they don't have a charge. Okay, let me just show you a visual picture of this. The nucleus of an atom, we have protons and neutrons. Okay, so this is how it looks. I want different picture. Here is it. So you can see that this is the nucleus, right? We do have what? Protons and neutrons. Okay, that's the nucleus. But around it, we have electrons there. Okay, but in the nucleus, there is protons and neutrons. Okay, and that forms the mass of that atom because electrons are very small such that we can neglect their mass. Okay, so if you want the mass of an atom, what do? Mass of an atom, you say what? The number of what? Protons plus the number of what? Neutrons. They're the center. They're the one that determine the mass. Okay. Which subatomic particle is negatively charged? We know that it's what? Electrons. Electrons are the one that are what? Negatively charged. What is the atomic number? When we say atomic number is the number of what? Protons. Guys, in your periodic table here, here, this is number 1. Hydrogen has atomic number 1. What does it mean? It has 1 proton. Helium has atomic number 2. What does it mean? It has 2 protons. Lithium has atomic number 3. What does it mean? It has 3 protons, right? Remember this number here on top, the smaller number in your periodic table shows the what? The atomic number, right? So this one will show you the atomic number, the smaller number, atomic number, which shows you what? The number of what? Of protons. Okay. Not only number of protons, it also shows us also the number of what? Of electrons, which are the same. So this 5 here is showing that boron has 5 protons, also have what? 5 electrons. Okay, that's the atomic number. Okay, it also shows you the number of electrons, number of protons, but most importantly, number of protons. Okay, then that is it. Then we do know that the atomic number shows us the number of protons, right? Why don't we choose number of electron? Electron can change, guys. Remember, if it's an element that is H plus, it means because it's now positively charged, it means it lost 1 electron. You understand? Hence, you can't because H. So the stable number is protons because protons you can't lose them. They're the nucleus, right? Those you can't take away. An atom cannot lose its proton, but it can lose its electrons, right? But the proton there, the center, you can't lose those ones. The moment you try to separate proton, that's how Albert Einstein came up with the atomic bomb, and it had led to destruction, because the moment they separated the protons and neutrons, they formed an atomic bomb. And because there's so much energy in the nucleus of an atom. Okay, so that's the idea then. Then let's come here. The number of significant figures in this value. When we speak about significant figures, guys, there are rules, right? So the rule says all non-zeros are significant. Another one, it says what? If there are zeros between non-zero numbers are also significant. So if you have zeros between non-zeros, they will also be significant. Okay. So let's look at this. How do we count the number of significant digits here? We can first write it in decimal, right? Let's write it in decimal. So I can say this is 8,6002 times 10 exponent minus 2. All right. Then you can see it's 0.086002. Okay, so that value is the same as what? 0.086002. Then let's count significant digits, right? All non-zeros are significant. So 8 is significant, number 1. Number 2 is significant. 6 is significant. The zeros are between two numbers that are non-zeros. So they will also be what? They will also be significant. So it means that this zero is significant, this one is significant, this one is significant. How many significant digits? It's 1, 2, 3, 4, 5. So you can see it's 5 of them. So there are 5 significant digits. Then the answer there is 5. Okay. In the periodic table, in the periodic table, the elements in this group are termed alkali metals. You know that alkali metals are in group number 1, right? These are alkali metals, right? Those are alkali metals. You know that in group 7 here, these are what? Halogens, right? Halogens. And these are what? Are noble gases. They can form noble gases. So you must understand those things. So these ones are alkali metals. Alkali metals. Group 7, halogens and noble gases. And transition metals, I think it's in between there, right? Transition metals. Yeah. So that is it. So obviously, alkali metals, group 1. Okay. Then let's move. The number of electrons in a neutral atom of ion 26. Ion is Fe. If you check in the periodic table, Fe, can you see it here? It has an atomic number of 26. So a neutral Fe will have 26 protons and 26 electrons. So they need the number of electrons. So it'll be what? 26, because it's neutral. When it's not neutral, I mean, they can give you Fe2 plus, right? This shows that Fe has lost 2 electrons because it's now positive by 2 plus. It shows that it has lost 2 electrons. So you go to the periodic table, it's number 26. So it had 26 electrons, but if it's 2 plus, we minus 2 because it lost 2 electrons. You don't add 2. Don't confuse this 2 plus to say you're going to add 2. It shows it lost 2 electrons. Then you minus 2 from the 26 electrons. Then it will have Fe2 plus will have 24 what? 24 electrons. All right. What about if you are given Fe minus? If it's minus, it has gained one electron. But if it's Fe2 minus, it has gained how many electrons? 2 electrons. All right. So it means that from the 26, this one Fe minus, it gained 1 electrons. We're going to add 1 electrons, then it's 27 electrons. Fe2 minus, it gained 2 electrons. Then from 26 electrons, we're going to add 2, then it's going to be 28 electrons. So, but the neutral one is just Fe. So it has 26 electrons. All right. I hope that makes sense. Let's move to this one. Which of the following exhibit the greatest metallic character? Now, with this one, if you observe these elements here, you'll find that they're all metals, right? Alkali metals, by the way. Which one will exhibit the greatest metallic? Let's observe them. RB, K, Na, and Cs. Here they RB, K, Na, and Cs. Which one exhibit the greatest metallic character? They are all metals, but the one which will have the greatest metallic character is the one with more metal atoms. So the one with higher atomic number, because it shows that it has a lot of atoms. So if you have a lot of atoms that are metals, then you'll exhibit the greatest metallic character. So between them, which one has the highest atomic number is Cs. Can you see? It's 55. It's the greatest atomic number from all of them. So it has more metallic atoms. So then it will be the one that exhibits the greatest metallic character. All right. What is the total number of valence electrons in ammonium ion? Valence electrons are the electrons that are pairing, right? So for you to determine the valence electron, this you have to draw kind of like a Lewis diagram. Nitrogen is in group number 5, right? If you check nitrogen, let me just clean my periodic table. Nitrogen is in group number 5. So it has 5 valence electrons. 1, 2, 3, 4, 5. However, guys, there are 4 hydrogens, right? Hydrogen is in group number 1. So hydrogen brings only 1 valence electron. Each hydrogen comes with 1 valence, right? 1 like this. There are 4 of them, 1, 2, 3, 4. But this thing is plus. It shows it has lost an electron here. So nitrogen has lost 1 electron. So I'm going to delete 1 electron. So it's left with 4. It's in group 5. It had 5. But because it's plus, lost 1. I remove 1. Then I put my hydrogen comes and pair and share the electron pairs. For them to bond, they must share the electron pair. All right. That is our, oops. This is our NH4 plus, right? I mean, some people might like to represent it using lines, right? Like N, H, H, like that, 4 of them around, you know. But you won't be able to count if you use this. It's easier to count the valence electrons, those ones that are pairing. 2, 4, 6, 8. So we know that the answer is B. Okay, but anyways, you know, about according to the octet rule, there must be 8 around for it to, like, if it has to be complete, you understand? So yeah, the valence electrons in metal crystals are what? Okay, I know this might be confusing. Let me show you this first and we can choose the answer there. This is a crystal metal, guys. And what's happening in this crystal metal is that it has positive charges. So the figure, that rigid figure, is formed by those positive charges. Now, what is happening is that these electrons, they are free to move between any of the 2 atoms. So it's like these electrons, they can move. So you can see with those arrows, it's showing that they can move. You understand? So they can move between any of the 2 atoms. So they are delocalized between any 2 atoms. That is, they are not fixed in a particular position. They can move between any of the 2 atoms. All right. Then we can check our options here. The valence electron in crystal metals, obviously it's A, delocalized between every 2 atoms. Okay, that's the idea. 16, the nucleus of 200 Hg, I think Hg is mercury, right? Nuclide contains, we're being asked, it contains what? Let's go to Hg. If you check Hg, guys, yes, Hg, you can see that it is its atomic number is 80, right? So it means that it has 80 what? 80 protons. Then 200 Hg, it means that this is its atomic mass, right? So the mass is what? Is 200, because here they give you 200. I mean, you don't come to a predict table and use 200.59 because they told you the one that is 200. You understand? So they already give you the mass 200. Because mass is formed by what? Protons plus neutrons. We can now calculate neutrons because we know protons, they are 80. It's atomic number, right? 80. So if you put 80 and you are trying to look for what? Neutrons, you say neutrons is going to be what? 200 minus 80. Okay. Then there will be how many neutrons? 120. So we can talk about Hg. It has 80 protons and it has 120 neutrons. And together, when we add them, they give us that mass number of 200. Okay. So we can choose the correct answer: 80 protons and 120 neutrons. Can you see? That's the correct answer, the C. 80 protons, 120 neutrons. All right. Okay, let's go to 17. Which of the following statements is the most correct about one formula unit of MgCl2? We know that MgCl2 is the same as what? If you look at those things of ions, standard table for ions, all right? If you check that thing, Mg is 2 plus, right? Here is it, magnesium. Let me copy this here. Oh. Here is it, standard table for ions and cations, right? Cations, rather. Mg is 2 plus, can you see? And Cl is minus. So now in this statement, Mg here, we know that it's Mg2 plus ions and Cl minus ions, but how many of them? 2 of Cl minus ions, because it's Cl2. So the correct answer will be D, isn't it? That it is composed of 1 Mg2 plus and 2 Cl minus ions. All right. Let's move. A certain element is listed as having an atomic mass of 63 atomic mass unit. It is probably true that this element contains a mixture of what? Isotopes. What are isotopes, by the way? Isotopes. These are elements with different masses. Oh, sorry. Let's say elements with same atomic number. When we say they have same atomic number, we mean they have same number of what? Protons, but different mass number. So it's like the same, sorry, it's like the same element that belongs, it's like the same element, like carbon 12 and carbon 14. It's same element, is carbon. If you check in the periodic table, carbon, it's in group number what? 6. Can you see? So carbon group number 6, it has the same atomic number. What is the atomic number? It's 6. Can you see? The atomic number is 6. I mean, it's carbon, by the way. Both of them are carbon. They have atomic number of 6. However, they have different masses. This is the mass number. Can you see that their masses are different? This is 12 atomic mass, and this one is 14. Different atomic masses means that they have different neutrons, right? Because protons are 6, both of them have 6. But if I need neutrons, I'll go to the mass, I minus protons. This will be 6 neutrons. Here, I go to the 14, I minus protons. This will be what? 8 neutrons. So you can see both of them are carbon, but they have different masses. But different masses means they have different number of neutrons. So isotopes are those with the same atomic number, but different number of neutrons. And different number of neutrons means that they will have different masses, because neutrons is what? Protons. Mass is what? Mass is made up of protons plus what? Plus neutrons. Okay. So if the protons are the same but different neutrons, their masses will be different as well. Isn't it? So that's the case. So we do understand that, if you are given an atomic mass of like that, we can argue that it's probably true that this one with this atomic mass will probably have a mixture of isotope, that is the same elements but with other different masses. If a mixture contained undissolved particles that are mixed evenly throughout the liquid, it is a what? It is a suspension, right? This is a suspension. It cannot be pure, because if it's pure, it won't have undissolved particles because it's pure. It can be a solution, because a solution is dissolved, right? So it doesn't have those undissolved particles. Also, a precipitate is formed when they have dissolved, so it doesn't have undissolved things. So it's a suspension. Filtration is used to separate what? Those things that are insoluble. Insoluble substances from water, right? We can use filtration. Like you can filter them because they are insoluble. However, if they are soluble, like salt that is dissolved, you can't use filtration, right? You probably use distillation for soluble, but insoluble substances from water, we use filtration. What is the number of each type of atom present in a molecule of this one? SN3, there are 3 SN, right? What about P? P times 4, there are 4 of them, of the P's. So 3 SN, there are 4 P's. Oxygen is 3 times 4, it's 12 oxygen. So the correct answer will be what? B, right? It's 3, 4, and 12. The law of conservation of mass states that what? The total mass of the products of a chemical reaction will be the same as the total mass of the what? Of the reactant. All right. Because the mass is conserved. So the mass in our product and the reactant will be the same. All isotopes of an element have what? Have different atomic number. Wrong. They have the same atomic number. I've discussed this because it's like carbon and carbon. They have the same atomic number, right? But so they can have different atomic number. However, they will have, by them having the same atomic number, they have the same chemical properties. Okay, because it's both carbon, both of them are carbon. It's just they have different masses. They have different number of neutrons. So their chemical properties will be exactly the same, because chemical properties of an atom is determined by its atomic number, the number of protons they in the nucleus. It's what determine this one is this. If it has 1 proton, it's hydrogen. 2 protons, it's helium, like that. 3 protons, it's lithium. 4 protons, beryllium. 13 protons, aluminum, like that. Okay. So isotopes have the same chemical properties. They just have different masses because they have different neutrons. Which symbol represents the atom with the largest number of neutrons? So it's between this one and this one, isn't it? Because their mass is 234, 234. So you see, both of their masses are 234. So to get neutrons, remember mass is equals to what? Protons plus neutrons. So we can get the neutrons of this one, right? Because the mass you are given 234. What is its proton? You check its atomic number, TH. If you look at TH, TH is somewhere here. Can you see? It's number 90. Can you see? The atomic number is 90 here. They've given you the mass number already, right? They said 234. You don't have to check the one in the periodic table because they gave you it's 234 of TH. So the mass is 234. Similar to uranium, 234 as well. The number of protons, we're going to the periodic table to say it's number 90. So to get protons, it's 90. Then we can calculate neutrons, right? So neutrons will be 234 minus 90. That's neutrons. Then we say 234 minus 90. It's 144. So it has 144 neutrons. So A has 144 neutrons. Let's calculate uranium. So uranium, we're going to say 234. We minus the protons. Uranium is number 92. The protons is 92. We minus 92 to get neutrons. So 234 minus 92. 142. So 142 neutrons. Uranium, it's 142. So the one with the highest, largest number of neutrons will be TH. Can you see? It's 234 of them. Oh, sorry, it's 144. What am I saying? We found TH is the one with the highest. What is the correct name for this one? How did we form SN3PO42? SN3, it has a 2 plus. You understand? From the, where is it here? We even have it from this table, SN3. But it's like 2 plus. Okay. Then PO4, SN. Why am I saying SN3? SN is 2 plus. Right? SN has a like a 2 plus. Why am I saying SN3? SN has a like a 2 plus. Okay, I can't see it here. So, but it has a 2 plus. PO4, can you see PO4 here? It has a 3 minus, right? PO4. The 3 minus. So what happens when you want to determine its thing to balance? What happens is that these 3 here will come here and these 2 will go there so that we balance their number of protons and electrons so that it's neutral, right? So it will be SN3 PO4, the 2 goes there, 2. Can you see? Like that. So which one will be the correct one here? In terms of the choices, the correct name of that one, SN3. So it must be 2. It had to be 2 plus. So this one is tin 2. So the tin must be 2 of them, 2 plus, so that, you know, that one goes there. All right. Then pure 4 like that, phosphate. it comes with the 3 minus. So it must be 2, 2 plus. You understand? So that 2 goes there, the 3 of the phosphate comes here. So the correct answer is that one. Balance the following. We need to balance. There are 2 Fe here. Ion. There's 1. I'm gonna put a 2 here to balance ions. Oxygen, there are 3. Oxygen here, there are 2. Okay. So let's see if I put 2 them of Fe, then I've balanced the Fe. What about oxygen? Here there are 2 oxygens. Here there are 3. If I put a 2 here, I make this oxygen to have like 6, right? Then here I'll need to put a 3. So that here I make this oxygen to have what? To have 6 as well. However, Fe is no longer balanced. Here Fe there are 4. I'll need to put 4 here. Let me see. Then carbon there are 3. I put 3 there. So it's 2, 3, 4, 3. 2, 3, 4, 3, which is C. Okay. What type of reaction is the following? Now, Ba is a metal and a sulfate. So this is a solid. It's a it's a precipitate. This is a metal and a sulfate. It forms a precipitate, right? And an aqueous, sodium chloride aqueous. Because there's precipitation formation, this will be what? Precipitation reaction. Okay, that's precipitation reaction. Let's go to 28. All of the following statements about different elements are true except what? Aluminium is not a transition element. This one is not true. Because if you check, aluminium is here. Transition are here. You know, these are transition elements. So aluminium is not part of transition elements. Okay. Aluminium is not. What is the mass of 2.5 mole of water? So the mass, number of mole is equals to mass over molar mass. H2O. Let's get its molar mass. There is 2H. Molar mass, you go to the periodic table, you check that number. The one you are given in your periodic table, 1.01. That's the mass of one hydrogen, 1.01. Because there are 2, we multiply with 2. I think 2,02, I think. Oxygen is what? 16.00. That's the molar mass or the mass. 16.00. Then for H2O, we're going to add this 2.02 plus 16. I think 18.02. That's the molar mass. Number of mole is 2,5. So to solve for mass, you can cross multiply. So mass will be equal to the number of moles times molar mass. So it's 2,5 times molar mass 18.02, right? Let's calculate this. 2.5 times 18.02. 45.05. 45.05, which aligns with what? With B. That will be the mass. Okay. Similar question again. What is the mass in grams of 0.0735 moles of NaHCO3? Let's first find the molar mass, right? Molar mass, NaHCO3 4,3. Na, let's check Na. Where is Na? I'm looking for Na. Here is it. 22.99. That's the molar mass. Hydrogen 1.01. Carbon 12.01. Oxygen 16.00, which is like 16. But because there are 3 of them, we times by 3. Then we add this to get the molar mass, right? Like 22.99 plus 1.01 plus 12.01 plus 48. Then the answer will give us plus 48. 84.01. That's the molar mass, right? I'm looking for number of moles. No, mass. Mass equals to number of moles times molar mass. Number of moles were given 0.0735 times the molar mass 84.01. Then we get the answer. So 0.735. 6.174 grams. Can you see? 6.174 grams. Let's check the correct answer here. It's closer to this one, B, right? Which is 6.325. Okay. That is the correct answer there. When aqueous solution of this one and this one are mixed, does a precipitate form? Remember, precipitate will be that solid that will be formed. PB and I, what will happen between them? I think it will be a solid, right? There will be a formation of a solid in that reaction. So I think yes, a precipitate does form because a solid will form. What is the state of water at room temperature? Room temperature is 25 degrees Celsius, guys. Water, obviously, at 25 degrees Celsius is liquid, isn't it? At more than 100, it becomes gas. At below 0 degrees, water is ice, solid, isn't it? But between 0 to 100, our water is still liquid. 100 is boiling point. So at room temperature 25, water is liquid. All right. Liquid pentene burns in oxygen gas to form carbon dioxide and water vapor. Write a balanced chemical reaction. So it's C5H10. Let me write it maybe somewhere down here. C5H10 burns in oxygen, is being exposed to oxygen. This is combustion. It forms carbon dioxide and what? And water. Right. Now, let's balance. There are 5 carbons. There's only 1 carbon. I put 5 here to balance the carbon. There are 10 hydrogens. There's only 2 hydrogens. I put at 5 here. To say 5 times 2 is going to give me 10. Only 2 oxygen here. Here there are what? 5 times 2, 10 times 5 there plus 5, 15 oxygens. Can you see? On the product, there are 15 oxygens. But here I only have 2. How can I make them the same? I can multiply by 15 over 2, right? 15 over 2 times 2 will give me 15. So here I can put 15 over 2. All right? So that 15 over 2 times 2, it gives me 15 oxygens. So to just make them in like not to avoid the fraction, I can multiply everything by 2, right? It will be what? 2 C5H10. If I multiply here by 2, 2 and 2 will cancel. I'll be left with 15O2. I multiply by 2. Remember, I'm multiplying everything by what? Everything by 2 now to take out this fraction. 2 times 5 is 10. 2 times 5 is 10. Can you see? So it corresponds with which one? 2, 15, 10, 10. B, right? The correct answer. Okay. A rocket propellant composed of hydrazine and hydrogen peroxide. Balance the chemical equation for this reaction. Okay, you must understand here hydrazine, right? A rocket propellant composed of hydrazine and hydrogen peroxide, right? Balance the chemical reaction. Okay, so let's see how we're gonna balance this one. So you do understand that hydrazine, it's N2H4, right? N2H4, right? Now you need to know whether hydrazine is a liquid or solid, right? So this was kind of like a tricky question because you need to know whether it's a solid or a liquid, right? But at room temperature, really, it's actually a liquid, right? So you don't understand that in this case, N2H4 hydrazine with hydrogen peroxide H2O2. So we'll choose the one that is liquid, right? Because hydrazine is liquid at room temperature, mixing with this to form nitrogen gas and this, which is balanced, right? So the correct is D there. What is the mass of 2.5 mole of 2 water molecules? Remember, this question came, but they just say water molecule. Now they say 2 water molecule. Mass equals to number of moles times molar mass. I think we had already calculated molar mass of 1 water molecule, which was 18.02, right? So if there are 2 of them, we just double the molar mass. So it will be 18.02 times 2. Which is what? 36.04. 36.04. Now, the number of moles is 2.5. The mass is 36.04. Multiply those, then you get the answer. Times 2.5. It's 90.1 grams. Can you see? So the correct answer there will be 90. When there are 2 water molecules. Remember, when it was just water molecule, it was just 45. Now it's 2 water molecule, it's 90. All right. 36. What is the mass in grams of this one? I think we have calculated this before, eh? I think we got 6.174 grams. So we'll choose this one. It's closer to that. From the following chemical reaction, how many grams of HCl are required to react with 25 grams of MnO2? Right? How many grams of HCl are required to react with only 25 grams of this one? So if you check MnO2 and HCl, they have a ratio of what? 1 mole is to 4. Do not be tempted to make a ratio using the mass, because this is the mass, guys, right? It's not the number of moles. You first need to calculate the number of moles. This is called the mole ratio. You don't make a ratio using mass. So you can't say 25 grams here and you say X, you look for it. Most people, you probably get, something else there, and I mean, it won't be correct, really. So you have to calculate the number of moles of this one. So number of moles is mass over molar mass. Its mass is 25 grams. Molar mass Mn, let's go to the periodic table. Mn and O2, I think O we already know it's 16, because it's two of them, it will be 36. Molar mass Mn, what about Mn? Let's look for Mn, manganese. Mn, here is it, 54.94. Can you see? So Mn is 54.94. Now we can find the molar mass. We add the two, 55.94 plus 36. 54.94 plus 36. 90.94. That's the molar mass, 90.94. Then we solve for, number of moles. 25 divided by this answer, 0.27 or 0.3, right? 0.3 mole. Can you see? We got 0.3. Now you can make a ratio, because MnO2, you are given the mass. You had to calculate number of moles. Then you make a ratio. We can put 0.3. We don't know the moles of this one. Number of moles of HCl. We make a ratio 1:4. It's 1:4. Can you see? 1:4. We know this one, it's the number of moles 0.3. We just calculated. We cross multiply to get the number of moles of HCl. When we cross multiply, it's 0.3 times 4. The number of moles, it's going to be, I think, 1.2 moles, right? We are not looking for moles. We want its mass. You understand? They said what mass. So we know that number of moles is mass over what? Molar mass. We know number of moles is 1,2. We are looking for mass. What's the molar mass of HCl? H is 1.01. Cl, it's what? H is 1.01 here. It's molar mass. What about Cl? It's 35.45. We're going to add the two to get molar mass. 35.45 plus 1.01. 35.45 plus 1.01. So its molar mass is what? 36.46. Okay. 36.46. We cross multiply to get its mass of HCl. So the mass will be 1.2 times 36.46. So the mass is what? 43.8. Can you see? We're getting the mass of 43.8 grams. Okay. 43.8 grams. So it's kind of closer to 42, right? So the correct answer there will be 42 grams. Okay, that is it. How many particles? Oh, let me delete here because it's a bit of a mess here. Now let's go to 38. How many particles, How many particles are in 1 mole of H2O molecules? Right? How many particles are in 1 mole? Number of particles, you say number of moles times Avogadro. Number of moles is 1 mole. Avogadro's number is 6,022 times 10 exponent 23. So it will be 6,022 times 10 exponent 23 H2O what? Particles or molecules, right? So it's 6,022 times 10 exponent 23 H2O molecules. There is it. It's this one. Calculate the number of hydrogen atoms in 0.35 mole of this one, which is glucose, C6H12O6. How many hydrogen atoms are there? We know that the number of atoms, right, will be, the number of atoms, no number of atoms will be the number of moles times Avogadro's number, right? But here, guys, you are given it's 0.35 mole of this whole thing. So it's 0.35 of the whole C6H12O6. But you need for hydrogen atoms. How many hydrogen atoms do we have? It's 12 of them. So we're going to multiply this number of mole by 12 because we are looking particularly for those hydrogen times Avogadro's number, 6,022 times 10 exponent 23. Okay, then we can determine how many hydrogen atoms are there. So we are saying it's 0.35 times 12 because there were 12 hydrogen atoms in that molecule times 6,022 times 10 exponent 23. Okay, then we get what? 2.5 times 10 exponent 24. Okay, 2.53 times 10 exponent 24. So the answer is A. 2.53 times 10 exponent 24. All right. How many oxygen atoms are in this one? It's kind of like the same question, eh? Oxygen atoms, the number of oxygen atoms, it will be the number of moles, 0.25. Then we see how many oxygen atoms are here. There are 3 times 2, can you see? Which are what? Which are 6. So we multiply that number of moles by 6, then we multiply with Avogadro's number. Then to get the number of oxygen atoms. All right. So this will be 0.25 times 6 times 6,022 times 10 exponent 23. 9,033 times 10 exponent 23. 9,0 times 10 exponent 23. 9,0 times 10 exponent 23 oxygen atoms. So the correct answer is C, right? It's not 1023 here. It's an exponent. It's just I couldn't write it as an exponent, but it's an exponent there. 9,0 times 10 exponent 23. How many oxygen atoms are in 1,5 mole of sodium carbonate? Right? How many what? Oxygen atoms. Now, they're making it tricky because they're giving you sodium carbonate. So if you don't know how to write the name of sodium carbonate, then you'll have an issue, right? Sodium, it's Na, right? So carbonate is CO3, but however, carbonate has like 2 minus. Can you see? Yeah, carbonate 2 minus. So because this one has 2 minus, this one has a plus, Na plus, if you check here. This is like Na plus. Can you see? Na plus, sodium. Now to determine its name, you say this one to balance, these two will come here, the one goes there. So it'll be Na2CO3. Can you see? Because here it receives the one, the two comes to Na. So that's the name. So how many oxygen atoms are there? So the number of oxygen atoms will be the number of moles, it's 1,5 times how many of those oxygen are there. There are 3 of them in that sodium carbonate. Then you multiply with Avogadro's number. Because it says in 1 mole there are 6,022 times 10 exponent 23. Hence we multiply with it to get how many of those, right? So in this case, it's 1,5 times 3 times 6,022 times 10 exponent 23. 2, what? 71 times 10 exponent 24. 2,71 times 10 exponent 24, which aligns with C. Can you see? Aligns with this one. All right. What is the molar mass of glucose? Glucose is C6H12O6. All right. Let's calculate its molar mass. C, it's in its molar mass, it's 12.01. Can you see? So this is 12.01. There are 6 of them times 6 plus hydrogen is 1,01 times 12 plus oxygen is 16 times 6. Then we can get the answer of that. All right. Let's see. So it's 12.01 times 6 plus 1.01 times 12 plus 16 times 6. Then it's 180.18. So it's somewhere around 180 grams per mole. So the correct answer there will be C. All right. Calculate the number of moles of glucose. This is glucose, C6H12O6, in 5.380 grams of glucose, you know. So the number of moles is going to be what? The mass over molar mass. 5.380. That's the mass. Molar mass, we have calculated it. It's around 180, right? So it's 5.380 divided by this answer here. Then the answer is going to be 0.0298 which is A. Can you see? The correct answer is A. 0.0298 whatever. It's A. Okay. Let's go to C. How many copper atoms are in 3 grams of pure copper? How many what? Copper atoms are in 3 grams of pure copper, according to Avogadro? In an atom, in 1 mole of something, there will be 6,022 times 10 exponent 23 atoms. So in pure copper, there will be 6,022 times 10 exponent 23 atoms. It's Avogadro discovered that. In a mixture of 10 mole of hydrogen and 7 mole of oxygen, which react to form water, which substance is the limiting reagent? This is an important question. Which one will be a limiting reagent? How do you determine? You can first write an equation, right? I mean, oxygen gas, hydrogen gas, they react to form water. We can balance 2 hydrogen, 2 oxygen. Here there's 1 oxygen. I put two oxygen now. Now there are 4 hydrogen. I put 2 there. Right? Now look, if you need to see the limiting reagent, if you make a ratio of hydrogen gas and oxygen gas, it's going to be more ratio 2:1, right? 2/1, which gives us 2. Can you see? However, if you make using this 10 mole of hydrogen, 10/7. So if you see 10/7, it's going to give us 1, what? 1,4 something. Can you see that there's a decrease in terms of when hydrogen, this one was more, this one it's decreased. Can you see? So which one is in excess now? That caused a decrease. Which one is in excess? Can you see that we can agree that, okay, because 2/1 is 2. Now when we make this 10 mole of hydrogen and 7 of oxygen, it has decreased that ratio. Now, because it's less, so we can agree that oxygen was in excess, was more. That's what caused the decrease, right? It was 2:1, but then when you make using those, there's a decrease. Oxygen is in excess. It means now hydrogen gas is what? Limiting reagent. Okay, so the limiting reagent here is hydrogen. What type of reaction is represented by this? A plus B combines to form AB. It's combination, isn't it? It's just combination. Which reaction occurs in photosynthesis? In photosynthesis, remember that plants absorb, take in water and carbon dioxide. I mean, and oxygen. I don't know. Is it carbon dioxide or what? Those who are doing life science will know better than to produce glucose. They produce one like thing. So it's synthesis. It's a combination. It's synthesis, right? They synthesizes those things to produce glucose. What is the chemical formula for table salt? Na what? Cl, right? In the equation, what is the simplified mole ratio of H2 in this equation? What's the simplified mole ratio of H2 and water? 2:2. When you check it, you simplify it 1:1 because it's 2:2. You simplified 1, it's 1:1. Right? What is the name of SO4 minus? This is what? Sulfate. Sulfate. A. What type of reaction is this one? So they are reacting to form one thing. It's synthesis, right? Just like in photosynthesis, those things will be absorbed, they combine to form one thing, glucose. What type of reaction is this one? If you see this reaction, H2O is being broken down into H2 and O2. This is decomposition, isn't it? H2O has separated to H2 and O2, has decomposed. All right. What is the formula of water? H2O, isn't it? What does the term mole refer to? Mole. When you say a mole, it means there are 6,02 times 10 exponent 23 atoms. That's Avogadro defines it, right? How many neutrons are present in an isotope of carbon 14? Remember, carbon 14 is the mass. We have to remove protons to get neutrons. Carbon is number 6, so it has 6 protons. So we remove 6 of those protons to get neutrons. So 14 minus 6, I think it's 8. So it will be 88 neutrons. Remember, mass is the same as what? Protons plus neutrons. So mass 14, protons is number 6. To calculate neutrons by subtracting 40 minus 6. That's what we did. What is the chemical formula for calcium carbonate? Remember calcium, Ca. If you check on the table, but this you must know by heart. Like what is calcium? It's 2 plus. You understand? So it's 2 plus. Carbonate. You must also know this by heart, guys. What is carbonate? It's 2 minus. Can you see? CO 3, 2 minus. So they are balanced. Can you see? They have the same. So you don't have to say this one goes here, this one goes here. I mean, it's balanced. You do that one there. So it's just CaCO3. Okay. 57. What is the coefficient of oxygen in a balanced chemical equation for a complete combustion of methane? Guys, combustion is this thing of methane will combine with oxygen to form what? Carbon dioxide and water. That's what you must know in a combustion. You react with oxygen to form carbon dioxide and water. Let's balance. There's one carbon, there's one carbon, there's 2 oxygen, 3 oxygen. We have a problem here because there are 3. However, 4 hydrogens, there are 2 only here. So let me put 2 here to make 4 hydrogens. Now, oxygen, there are 2 here. The oxygens here, there are 4. So I put 2 here to balance the oxygens. I think everything is balanced. What's the coefficient of O2 in this balance? So you can see the coefficient here is what? Is 2. All right. What is stoichiometry primarily concerned with? In stoichiometry, we are concerned with the quantitative aspect, quantitative relationship, quantity. It's coming from its number, right? We are concerned with those small ratios. That's the quantitative. It's the quantity aspect or relationship in a chemical reaction. What do coefficients in a balance equation represent? Coefficient represent the mole ratio. Guys, coefficient represent mole ratio, so you must calculate number of moles. You can't make a ratio between the mass. It's not mass ratio. It's not volume ratio. It's the mole ratio, right? The number of moles. 60. What is the percentage composition of hydrogen in ammonium nitrate? Percentage composition, guys. You have to calculate the molar mass of this thing, right? Of the whole thing. Let's calculate nitrogen, H4. So nitrogen, there are 2 of them, right? Because it's nitrogen and nitrogen. So let me say N2 or 3. Oxygen 16 times 3. Hydrogen 1.01 times 4. Nitrogen, let's see. Nitrogen, it's 14.01. So 14.01, there are 2 of them. So we add that to get mole ratio. 14.01 times 2 plus 1.01 times 4 plus 16 times 3. Oops. Back. 16 times 3. We add those things. We get what? 80.06. That's the molar mass. 80.06. Now, that's the total molar mass. We want for hydrogen. So for hydrogen here, if you say 1.01 times 4, I think it will be 4.04. 1.01 times 4. 4.04. That's the molar mass of hydrogen. There are 4 of them, right? So you're going to say the percentage composition is the molar mass of hydrogens that are there. It's 4.04 divided by total molar mass, 80.06. Then you multiply with 100. Okay, to get the percentage. So you get the molar mass of that answer divided by 80.06 times a 4. Oh, why am I timesing 4? Oh, I have to multiply by 100. 4, I'm saying 4.04 over 80.06 times 100 times 100. It's around 5%. Can you see? 5.0%, which is like 5%. So the correct answer is C. That's the percentage composition. All right. Calculate the volume of hydrogen gas in a standard temperature and pressure, STP, when 1.5 moles of zinc react with hydrochloric acid according to this equation. All right. Now, if you check, guys, you are given the moles of zinc 1.5, right? You need to know what is the moles of hydrochloric acid so that you can calculate volume, because now, you know, there's a formula that says the one with a VM. There's a formula that says, did I forget that formula? Number of moles is equals to the volume divided by VM. Now, VM, it's like standard volume under standard temperature and pressure, which is like that standard is 36 cubic decimeter. It's standard under standard temperature and pressure. The volume is 36 cubic decimeter. So if you need volume, you'll say number of moles times this VM, right? But we must know the number of moles of HCl because you are given the moles of zinc. So you can use a mole ratio, right? Using mole ratio, guys, you understand that it's 1:2. So the number of moles of zinc is 1,5. You don't know the number of moles of HCl. Cross multiply. So the number of moles of HCl will be 1,5 times 2 because this one is multiplying with 1. 1,5 times 2, which is what? 3 mole. Right. Then because it's 3 mole, is it 3 mole really? Let me see. 1,5 times 2, but it should be 3 mole. Oh, I'm wrong. Oh, times 2, man. Yeah, 1,5 times 2 is 3. Then VM, hey, let me verify, guys. I think I've forgotten as well. Standard volume because I might be wrong here. I don't think it's 36. I think I'm wrong. 22 point something. Standard volume and pressure of gas. It should be 22.4, I think. Yeah, 22.4. That's the standard. So number of moles, we have calculated 3 times what? 22.4. Is it 22.4? Let me verify, guys. Were you not given data sheet here? This is a past paper. Most of the question I take them from these past papers. So, where is this standard, man? Hey, man. Look at me forgetting the standard volume. Okay, I think it's 22.47. I forgot. Let's see. We're getting funny answers here. Okay, let me. Okay, let's see. Because if we forgot this. Because they said what? It's me who's wrong. Why am I calculating for ACL? Maybe some of you were confused. What is it doing? Why are you doing a ratio for zinc and ACL? What's happening? So I'm wrong. I'm supposed to do for hydrogen gas, right? I'm wondering the answer is not in the option. It's zinc and hydrogen gas. It's 1:1. So it means 1,5 mole of this one will be the same as 1,5 mole of that. So the number of mole is 1,5, right? Because it's 1:1 ratio between these two is 1:1. So if you say 1,5 times 22.4, then which is the standard, 1,5 times 22.4, then we get what? 33.6 cubic decimeter. So the answer will be A. All right. This you had to know that the standard VM, I mean, they didn't give you this formula, guys. You need to know it by heart. V equals to N times VM. In the reaction, which one is the limiting reagent? This question again of limiting reagent. We got 33.6 cubic decimeter. Okay. Now, in this reaction, which one is the limiting reaction? By looking at mole ratio A over B, it's going to be 2 over 3. Can you see? Which is like, if we say 2 over 3, it's like 0.7. Now, if we use this moles, 4 moles of A over 6 moles, it's 2 over 3. Hey, we're getting the same answer. So the ratio is the same. So it means none of them has limiting reagent. It means both of them will be completely used up because the ratio is the same. But if we had gotten less, like maybe it was 0.3, just like last time when we got less, it means that B would be in axis, isn't it? Because it was dividing more, it's in axis, then A would be limiting. If we got more, it means more, A was in axis, then B would be limiting. So in this case, the ratio is the same. for their mole ratio and using this MOS. So neither of them are limiting. None of them. They are completely used up. All right. How many significant figures are in this value? There are only two, isn't it? 1, 2. Hey, guys, there's no 2 in the options. This is interesting. Am I wrong? Because this is like 36.00. Let's see something. There's a rule that says the 0 that comes after non-zeros, they're significant. I think that's why. Let's see if there's such a rule that really says. So the zeros that come after will also be, that are at the right of non-zeros, are significant. Yeah. So it's 1, it's 1, 2, 3, 4, 5. How many significant figures here? This is times 10 exponent minus 7. So it'll be, the minus 7 will be 0 0.1, 2, 3, 4, 5, 6, 0, 1, 8, 5, 0, 0, 0, like that. So how many significant figures are here? So it's 1, 2, 3, even the zeros that are to the right of non-zeros are significant. 4, 5, 6. Okay, there will be 6. Symbol for the element tin. What is the symbol for the element tin? It's SN, isn't it? Don't say TN, guys. Tin is SN. Which of the following is not the correct name? Right? Which one is not the correct name or symbol combination? Which one is not the correct name or symbol combination? I think it's arsenic, eh? If you check arsenic, arsenic is not AR, it's AS, isn't it? It should be AS. Arsenic is not the correct name symbol combination there. The rest, gold is AU, copper is CU, manganese is MN. Right. What does Rutherford's new findings suggest about the nature of science? I think I already explained this. Rutherford's finding, what do they tell us about the nature of science? That because Rutherford, discovered new things, and he disrepeated, J.J. Thomson's model, because Rutherford discovered the nucleus and it disregarded J.J. Thomson Plum-Parry model. That scientific knowledge is tentative. Tentative means it's changing, ever changing. It's not stable. It's not absolute. It's tentative. It can be changed over time. You understand? Scientific knowledge provides us with a way to present ideas that can be tested, repeated, and verified, and also disproved. Scientific knowledge is an attempt to explain the natural phenomena. That is also correct, but that's not what this one suggests about nature of science. Rather, what Rutherford's findings suggest, because he disproved J.J. Thomson's Plum-Parry model by saying there's a nucleus. So initially they believe, there's just this pool of positive charge and they are embedded in nucleus like Plum-Parry. But Rutherford says, no, there's a nucleus. So it's ever changing. It's not stable. It's tentative. Scientific knowledge is ever changing. Which of the following has 61 neutrons, 47 protons, and 46 electrons? Interesting. 47 protons. We are checking the one which is number 47, right? Okay, I think we can agree this one 47, This 147 protons. These ones are out. Oh, yeah, they're out because it's same 46 there. Protons, it's either the answer is between AG and this one. Let's check in neutrons. You're going to subtract, ne? Atomic number minus 47. You're saying atomic mass. Why am I saying atomic number? Atomic mass minus 47. This one is 61. What? 61 neutrons. But however, it has lost one electron. So from 47 protons, we understand this one has 47 protons. Because it's plus, it lost an electron. So we minus 1. So it will have 46 electrons. So the correct answer is B. Correspond with B, isn't it? That's the correct answer. Maybe 3 is 14%. Okay. Let's finish this question. We're almost done. There were a lot, eh? 69. The nucleus of a 207 Pb nuclide contain what? Pb. Let's check Pb. Pb, where is it? Pb. Ooh, Pb. Why can't I see you? Why can't I find you? You must be somewhere here. Where are you now? Guys, I can't find Pb. Oh, here's it. Look at this. Pb, it's 82 protons, right? It has 82 protons. Can you see? 82 protons. But you are given the mass. Ooh, what am I doing? Let me go here. 82 protons, that's Pb. You are given like the mass, eh? It's 207. So you know Pb is 82 protons. You are given the mass, eh? The mass is 207. So to get neutrons, you say 207 minus the protons, 82. Like then you get neutrons, because protons plus neutrons is the mass, right? I'm removing the 82 protons. 125 neutrons. So it's 82 protons and 125 what? Neutrons. Which of the following statement is true about, we've already solved this. Mg has 2 plus ions and 2 Cl minus ions, right? Then which of the following species all have the same number? The following species all have the same number of what? Let's see. It might be neutrons here because it can be protons because they are different here. Can you see? Protons is out. Maybe electrons. We don't know. So here, let's calculate electrons from each. 3 minus, it gained 3 electrons. So it's 15 plus 3. It's 18 electrons. Minus is it gained an extra electron. So it's 17 plus 1. It's 18 electrons. 2 plus, it lost 2 electrons. So it's 20 minus 2. So it's 18 electrons. Wow, interesting. They have the same number of electrons. Can you see? They're both 18, 18, 18. So you just calculate 3 minus, it gained 3 electrons. So for 15, you add 3, you get 18. 17, it gained 1 electron, you add 1, then that's it, that's it. All right. Which nuclide has the same number of neutrons as this one? Same number of neutrons. Calculate the neutrons. You say 14 minus 7 is going to be 7 neutrons. Which one has the same number of neutrons? You're going to minus 19 minus 9. It's going to give you 10 neutrons. 15 minus 8. I think this one will be the one because Let's see, 15 minus 8. Oh, oh, what's happening to my calculator? 15 minus 8, 7. Can you see? This is going to be 6. 12 minus 6 is 6 neutrons. 15 minus 7 is 8. So the one is B. It has the same number of neutrons as this one because 14 minus 7 is 7 neutrons. And here we also found 7 neutrons. What is the mass of 13.5 mole of water? We have already calculated the molar mass of water somewhere, right? It was 18.02. So the mass will be number of moles times molar mass. Number of moles 13.5. Molar mass is 18.02. You multiply the two, right? 13.5 times 18.02. 243.27 grams. 243, somewhere there, right? So the answer will be C then. How many moles of sucrose are there in 15.58 grams of this one? Of sucrose. How many moles? Number of moles, mass over molar mass. What is the molar mass of sucrose? Carbon. Molar mass carbon, 12.01. We're going to say 12.01 times 12 plus hydrogen 1.01 times 22 plus carbon 16 times 11. Then let's do this on the calculator. 12.01 times, 12.01 times 12. Then we say times 12, please, plus 1.01, 1 times 22 plus 16 times 11. 342.34. 342.34. So number of moles, the mass is 15.58 over 342.34. Yes. So it's 15.58 over 342.34. 0.0455. 0.0455. So the correct answer is D. What is the mass in grams of this one? I think its molar mass was 84.02 or something, eh? So the mass will be number of moles 0.06112 times the molar mass. Let's try that. Oh, 0.06112 times the molar mass. 5.135. Was that the molar mass of that? But yeah, I think it aligns with this one. Let me just Google the molar mass of NaHCO3. I'm tired, guys. I'm lazy to calculate it. Molar mass. Wow, it was 84, eh? So yeah, I think we were right. So it's gonna be 5 point something. So it aligns with B, right? Yes, it aligns with B. Yes, that is it, guys. This was the chemistry. I know it was a long session. It was a chemistry MCQ from past papers. I hope you find this helpful. Let me know from the comment section if you find this helpful. Don't forget to like, share, comment, and subscribe. See you soon on the next session, which we will be doing the MCQs from past papers for physics. Bye for now.